Well, when you think about materials, materials is very much an enabling technology.
Material science, materials engineering, it seems that not a lot of people know about it, right? We know because we are in the field, but not a lot of people really know what we're doing, and everything's really made out of materials. And if you look at the ages, the Stone Age and the Silicon Age, it's being named after materials, right? So materials is very important. Where is that materials plays a huge role? Of course, you went up in materials 100%, right? But but where is it like you see like something that could happen or revolutionize something soon?
Well, when you think about materials, materials is very much an enabling technology, right? It enables us to do things better in the areas of mechanical engineering, material science, chemical engineering. They're reliant on materials discoveries and pushing the envelope so that we're not doing the same thing we've been doing all the time. So I'll give you a couple of real quick examples, because most recently I've been working with the spacesuit, next generation spacesuit. And then there's two materials aspects that have enabled us to be able to come up with more creative solutions. So two things you have to have in the spacesuit, among other things, are you have to be able to take out the CO2 that you breathe in and out, right? And then you also have to be able to provide cooling to the astronaut. Well, in the old days, the Apollo days, and even in the space shuttle and the ISS days, they used either metal oxide canisters or lithium hydroxide canisters in order to basically as an adsorb bed for CO2. But once it was saturated, basically you no longer had capacity and capability in that canister, which meant that pretty much your EVA is over, right? And the only way that you can actually recharge it, you have to bring it inside, heat it up, desorb all the adsorbed gases, and then you've kind of replenished it. Well, the technology has evolved and changed so that we now use a zeolite bed as a catalyst that has the ability to desorb when exposed to vacuum. So it getters the CO2 from the airstream, and if you have two beds, one can getter the CO2 actively while the other one is venting to space without any additional heat. And this allows you to essentially have what used to be a consumable of the space suit now is no longer a consumable. It's no longer a restriction. That gives you much more capability in the spacesuit. The same thing with heat rejection. Heat rejection, in the old days, we used something that was similar to like a heat exchanger, a sublimator pack, which would involve taking a series of aluminum sheets that had very small holes drilled into them, and you built essentially a sheet of ice at the beginning of the EVA, and then we would eventually dissipate the heat by running your cooling water on one side, and the other side is exposed to vacuum, and you sublimate the ice off to have the heat rejection. Well, now we have membrane technology and polymeric membrane technology, which is essentially a permeable material that allows the hot water essentially to basically sublimate into the vacuum without ever having to build that ice pack. And you have a number of tubes, you can build in redundancy. And so this is the way that materials are used in a creative sense as we discover new capability for us to be able to then apply those to the problems that we have today. And they may not be trying to solve a problem that has never been there before, like new technology, but they could be improvements on technologies and that increases capability, like in the case of the spacesuit.